All right, today we're diving into something that is, no exaggeration, a potential game changer for how AI interacts with the world. It's called DeepSeek-OCR, and the best way to think about it is like a zip file for documents. It's a brand new way to get AI to read millions of pages, but way faster and way, way cheaper. Let's get into it.
So first, let's talk about a huge problem in the AI space. You've got an AI, and you want it to read, say, a 1,000-page legal contract or a dense scientific paper. Well, AI doesn't read words like we do. It reads tokens, and every single one of those tokens costs you. It costs you processing power, it costs you time, and it costs you real money. Now imagine you're a business that needs to process millions of documents. Suddenly, that cost isn't just a line item, it's a massive wall stopping you from doing what you need to do. And this really shows the difference. On one hand, you have the old way. It's like trying to drink from a fire hose. You just flood the AI with a massive stream of individual text tokens. It's slow, it's inefficient, and it's super expensive. But then you have this new way, the DeepSeek-OCR way. Instead of a flood, it takes an entire page and neatly packages it into a tiny, compact set of what are called vision tokens. The result? Costs get slashed, and the wait time just melts away.
And that brings us to the core idea here, what they're calling the compression paradigm. You have to understand, this isn't just a minor upgrade. It's not just a faster horse. It's a completely different way of thinking about how an AI should read in the first place. The fancy term for this magic is Contexts Optical Compression. Now, a regular old OCR, it just goes through a document trying to pick out individual letters, right? But this method is so much smarter. It looks at the entire page, not just the text, but the layout, the columns, the tables, the charts, all of it. And it compresses that entire visual context into one super efficient little package of vision tokens that the AI can understand instantly. And honestly, this is the perfect way to think about it. It really is like creating a high-fidelity zip file for each page. You know how a zip file shrinks everything down to make it easy to send? But when you open it, everything is still there, perfectly intact? That's exactly what this does. It shrinks the page down for the AI, but makes sure none of the important structure or information gets lost in translation. It's a fantastic analogy.
So how on earth does this actually work? What's the secret sauce? Let's pop the hood for a minute and take a look at the architecture. Don't worry, we'll keep it simple. It really boils down to a clever two-step dance. First, you have a component called the deep encoder. Its whole job is to look at the page image and do that all-important compression, crunching it down into just a few of those vision tokens. Then, its partner, the MOE decoder, takes that tiny compressed package and, well, it reconstructs everything, turning it back into the full structured text, tables and all. It's like turning a compressed blueprint back into a full-scale building.
Now this is where the design gets really smart. Look at that MO decoder. It has a whopping 3 billion parameters, which gives it some serious brain power. But, and this is the key, it uses something called a mixture of experts system. That means for any one job, it only has to activate a small fraction of those brains, just 570 million. Think of it like having a giant toolbox with every tool imaginable, but you only pull out the one specific screwdriver you need for the task at hand. You get all the power of a massive model with the speed and efficiency of a much smaller one. It's brilliant. Okay, so all that tech sounds amazing in theory, but what does it actually mean in the real world? Let's talk results, the speed, the savings, and the state-of-the-art performance, because this is where it all comes together. And this just lays it out so clearly. You get a choice. You can compress a document by 10 times and get an incredible 97.3% precision. That's what you need for critical stuff like legal contracts or financial reports. But let's say you're just trying to index a massive library of old books and speed is everything. You can crank the compression up to 20 times, take a small hit on precision, and still get really solid results. The power to make that trade-off is in your hands.
And the speed, it's just staggering. We're talking about a single GPU, a piece of hardware you can get commercially, chewing through more than 200,000 pages of documents every single day. Just one.
But of course, you don't stop at one. What happens when you scale this up? You put a small cluster of these GPUs together, and that number skyrockets to 33 million pages a day. That's not just fast anymore. That is industrial scale. That's being able to process entire national archives in a ridiculously short amount of time. What's also really cool is that it's not a one-size-fits-all solution. Developers can actually pick the right tool for the job. If you just need raw speed, you can use the tiny mode.
If you're dealing with incredibly complex tables and need every detail to be perfect, you switch to large. And for most things, there's the Gundam mode, which kind of does it all, finding that perfect balance between speed and accuracy for you. Okay, so let's zoom out for a second. This is about so much more than just making OCR faster and cheaper. What we're really talking about here are some pretty profound changes for the future of AI itself. So if you're going to remember 3 things from all of this, make it these. First, it absolutely demolishes the cost of letting AI understand documents. Second, and this is huge, it preserves the visual structure, so the AI doesn't just see words, it sees a table as a table. And third, that incredible speed means we can create the training data for the next wave of AI models faster than ever before. Ultimately, this is all about building a better foundation. When you can take messy, chaotic, real-world documents and turn them into clean, compressed, structured data, you're giving AI the perfect fuel to run on. You're giving these future AI agents a much better grounding in reality, which means they can reason and act with way more accuracy and common sense. And that leaves us with this really fascinating question to think about. I mean, documents are really just the start, aren't they? If AI can learn to zip up and understand the complex structure of a page this well, what comes next? Imagine it zipping up architectural blueprints to spot potential flaws, or compressing medical scans to find anomalies in an instant. This ability, this power to efficiently compress and understand our complex reality, well, that might just be the key that unlocks the next great leap for artificial intelligence.